Howdy team. In this problem we're going to describe how you find the acceleration due to gravity. That should say on Venus. The data over here is data for Venus. What data will you graph? How will you analyze the graph to find the acceleration? Now one thing that we know is that we can graph either position versus time or velocity versus time. Really, we can graph whatever we want, but those are two graphs that are really helpful for us to graph. If we graph velocity versus time, then the slope of that graph is the acceleration. So that's going to be a useful one for us to do. We could also graph position versus time. There would be another way to solve for the acceleration there. But right here, I'm going to show you if we graph velocity versus time, how to find the acceleration. All right, so how do we do that? What does this triangle T mean? That means change in time. Triangle means change in. So change in time is the change in time between these two data points, which is 1 second. All right, so I'll write 1. Now, between the next two data points, between 1 and 2, the change in time is also 1 second. The change in time between each of these data points is 1 second. Now what we have to do is we have to find the change in time. The next column is for change in position, right? So the change in position between the first data point and the second one is 12.3 meters. Then after that, to find the change in position from 49.2 to 12.3, just have to do a little subtraction there. We get 36.9. Feel free to do the same thing on your own calculator. 110.7 minus 49.2, okay, it's 61.5. Now I'm just calculating this along. 196.8 minus 110.7 is 86.1. Okay, it's a little bit tough to see. I'll write it bigger in a moment, but I'll say it aloud so you can hear. 307.5 minus 196.8 is 110.7. Okay. And finally, 442.8 minus 307.5 is 135.3. All right, the next column says T, and then in the lower is mid, right? What does that mean? It means T means time, right? And mid there stands for middle. It's the middle of these two times right here, right? And in the middle of 0 and 1 second is, of course, 0.5 seconds. And then in the next spot is in the middle of 1 and 2 seconds, which is 1.5 seconds. In the middle of 2 and 3 is 2.5. In the middle of 3 and 4 is 3.5, 4.5, and 5.5. Now you might be wondering, or I hope you're wondering, if you don't know the answer already, why we need to know the time in the middle of those two. It's because we're going to find the average velocity between time 0 and time 1, right? We know that as the object is falling, it's getting faster and faster and faster, right? So it's not going the average velocity at the very beginning, and it's not going the average velocity at the very end, right? In the beginning it's going slower, in the end it's going faster, right? What time is it going exactly the average velocity between 0 and 1 seconds? That time is the time in the middle, okay? So the time that it's going, the average velocity, is the mid time. Therefore, when we graph, we're going to graph these two columns here. Sound good? All right. Now, how we find velocity is change in position divided by change in time. So it would be 12.3 divided by 1, 36.9 divided by 1, and so on, right? So our answers will be 12.3 meters per second, 36.9 meters per second, 61.5 meters per second, 86.1 meters per second, 110.7 meters per second, and 135.3 meters per second. All right. We now have our data that we're going to graph. We have the velocity time data, and from that data, we're going to find the slope. here you can see I've made a scale on the graph, okay? At the bottom, it goes every other is 0.5, so that's 0.5, and then a 1. Then a 1.5, 2, 2.5, 3. Up here I go up by 5, so that's 5, 10, 15, 20, okay, and I mark the 20. 25, 30, 35, 40, mark the 40, right? You can see that I only get up to 110, or a little bit, that'll be 115, 120, which won't let me to plot the last data point. Bummer. That's okay. We know the shape, what the shape should be, right? The shape will be a straight diagonal line. We can find the slope with any 2 points, okay? So here we go. I'm going to plot at 0.5 and go to 12.3. That's a little bit between 10 and 15, okay? At 1.5, I'm going to plot 36.9. Again, that's a little bit below 40 there. 2.5, 61.5, okay? A little bit above 60. 3.5, 86.1. A little bit above 85 there. And 4.5, 110.7. Right there. Alright. Now this isn't a perfectly straight line because I don't plot my points perfectly, but I'm going to do my best to draw a straight line through them all there. Oh, that was pretty bad, but I'll try that again. Okay. Boom. All right, a little bit better there. Now, we have to find the slope of this line. Okay. How we're going to do that is we're going to take 2 points, right? These 2 points here, let's say, and we're going to find the rise over the run. We're not going to count the boxes, though. We're going to figure out how much the position rises. Okay, so the position goes from, right here it was at 86.1, and here the position is at 110.7. So we do 110.7 meters per second minus 86.1 meters per second. 86.1 meters per second. Okay, we're going to divide that by the run, right? At this point, it was at 4.5 up here, and here it was at 3.5. Okay, so we'll do 4.5 seconds minus 3.5 seconds. Go ahead and do that subtraction. 110.7 minus 86.1 is 24.6 meters per second. Divided by 4.5 minus 3.5 is 1 second. Okay, 24.6 divided by 1 is, of course, 24.6. So the slope, which is the same as the acceleration, is equal to 24.6 meters per second each second, meters per second squared. Our acceleration due to gravity on this planet is therefore 24.6 meters per second squared. All right. I just realized, because I know what the acceleration due to gravity on certain planets is, I realized that that is not the acceleration due to gravity on Venus. It is, in fact, the acceleration due to gravity on Jupiter. I was on the correct page when it said Jupiter there. So this data is for Jupiter. Those of you who have Jupiter on your worksheet and watch this video, you might be kind of lucky. You still have to write the description up here of what you did, summarizing what we did, and then your conclusion, right, saying that this is your acceleration. You know that from the graph, which is right here as your evidence. If you have any questions, I hope this video is helpful. Of course, you can ask me. Please finish both sides of your worksheet by Friday, or by next class period. Thanks.